moving beyond chat interfaces and single-purpose copilots into full systems that can act across full workflows. So what is the next stage of enterprise AI? Well, here to talk about just that is our first speaker, Colin Ife, Head of Risk at Geordie AI. His work combines technical innovation with strategic leadership, and he has a focus on responsible, scalable AI adoption. And there will be a Q&A at the end of his talk, so please get yourselves ready for that. But first, give him a huge welcome to the stage.
Good afternoon, everyone. And firstly, I'm happy to be at DataFest 2026, first time, but I'm also very honored to be here, to be invited. First time in Edinburgh as well, so looking forward to taking in some sights before I go back tomorrow. And yeah, my name is Colin Nwachukwu Ife. I'm here to talk about how enterprise AI is evolving in the real sense, in the practical terms. And this talk is not going to be about models or model capability. It's going to be about systems. So we're going to talk about what happens when intelligence gets embedded into real business workflows and under real operating circumstances. And what I'm going to do is try and strip away some of the hype around agentic AI and really focus on operational reality. And what I want to leave everyone here with is a clearer mental model of what mature AI adoption looks like. And again, this is all grounded in practice. All right, so two statistics I'd like to start off with, and I find them to be telling because they actually capture the illusion and the reality of agentic AI today, and especially in the enterprise realm. So the first stat is identified by KPMG, and they basically observed that 54% of organizations, as at the start of this year, they've reached agent deployment stage. So that means they moved beyond just experimenting with AI to wiring AI into real business workflows. Now, off the face of that statistic, that sounds like there's been some momentum, confidence in the technology, and there's been rapid progress, especially since last year it was about 11% at the same time, Q1 2025. However, the second statistic, and this is a prediction based off of what Gartner are expecting for 2027, and that's 40% of agent-based AI initiatives being abandoned, primarily due to a failure to scale. Now, I'm speaking as a practitioner here. I spent over a decade building AI systems from the ground up and deploying them. But that second statistic is not surprising at all. And the reason why it's not surprising for me is that I know that the real challenge isn't about building an impressive demo using AI. The real challenge is actually building the system around these models and deploying them under real circumstances and delivering value consistently. And the organizations that fail to recognize the shift from model-centric to system-centric AI, they're the ones who are going to struggle to scale. So before we go further, just a little bit about me, just to put this whole talk into perspective. So I'm the head of AI risk at Geordie AI. If anyone's interested, just feel free to scan. But yeah, I sit at the intersection of AI systems, security, and operational risk. As I mentioned, over the last 10 years, I've been building and scaling AI products in real deployments. And this is from research and development. I have a background, PhD in cybersecurity, but then through to customer deployments and obviously answering and solving real customer problems. And I care particularly about this topic because I've seen what happens when we move from just model outputs to those outputs then leading to actions, decisions, and operational consequences. So I'm talking as a practitioner, and for the rest of this talk, just recognize that the lens I'm bringing is talking about architecture, deployment, and again, operational reality. All right, so I mentioned this shift from model-centric to system-centric AI. And this slide, firstly, it just tries to capture where that shift begins in terms of interactions, how people have been interacting with AI over the last couple of years. And there's two models, two interaction patterns that I'd like to focus on. So the first is the Copilot. The Copilot basically is a human-led, turn-by-turn interaction pattern. It's one we're all familiar with as far as you've used GPT in a chat interface, or maybe you use it as part of your coding development environment. But it's all driven around the user. The user defines the task, the user drives the task, but the model just sits there to assist. It responds to queries, it generates responses, it provides suggestions. And even if it has access to tools or it has access to memory, the key determinant of success for that pattern is the capability of the model, how powerful the model is. Simply put, if the model is more powerful, is stronger, is updated, GPT 5.3 thinking, then you'll get better outputs. But a second interaction pattern, and this is something that we've seen emerging over the last year and a half, this is the agentic system. And the key thing about the agentic system, first, is goal-driven, but the model itself now sits within an orchestration layer. So that means it's coordinating tools, knowledge, memory, and other specialized capabilities, including other agents or specified evaluators for particular workflows. And it's doing all of this in order to push work through multiple steps towards achieving that goal. So the key shift here is that we're not just talking about models responding to users anymore. We're talking about models that are coordinating activity across tools and workflows and carrying out actions. And one last thing just to mention about agentic systems, because when you hear about agentic AI or agentic system, sometimes your mind goes immediately to autonomy, full autonomy. But in the enterprise realm, that is not what it is. What it really is bounded agency. And that means that these systems, they can act, but they act within defined limits. And in addition to acting within defined limits, there's also visibility and also controls about them. So those who are operating them have visibility into what they're doing, and of course, they can define those limits and modify them as required. Let's see. Cool. So Copilots, are they useless? No. I use the Copilot to create these slides. They generate value, and they'll continue to generate value when the task is mainly around generation. So if it's generating text, codes, images, summarizing context, doing analysis, they're going to continue to be great at that. And in fact, their value output increases as model capability increases. But then once the task moves from generation to execution, that's where we see the value plateau. And the reason being is that with that shift on the focal point of what a task is, we're now talking about not just models outputting to user response or user queries, but we're talking about work being done and work being put through multiple steps to achieving a goal. So that means you have a system that has to interact with third-party services and handle all sorts of responses. It could be errors in the APIs, it could be unpredictable responses, it can even be malicious responses designed to trick the system. You're having systems having to determine when it should continue with the task or if it needs to return back to the user for further feedback or guidance. All of this being done without explicit user direction. So the key thing to recognize here is that when we talk about AI executing, there's a creation of new failure modes. So the question is no longer, did the model create a correct output to a user prompt? The question now becomes, did the system act correctly? And what are the downstream impacts of those actions? And this shift I've been talking about for the last 3 slides or so. So this is this shift in a single slide. So when we talk about model-centric AI, the focus is about a prompt-response interaction. You give a prompt, you get a response. You give a prompt, you get a response. That's the scope of that interaction. When we talk about system-centric AI, it's now shifted to orchestration, workflows, and overall system behavior. The value driver for the model-centric AI point of view is the standalone model capability. But again, for system-centric AI, that's now shifted and is expanded to integration of those models into real workflows. And with that integration, we get new failure modes. So as I mentioned, with model-centric AI, it's all about the output quality of the model. Did it respond correctly or give a good quality response? But with systems, we're talking about action. Did it act correctly? And if it has not acted correctly, so it's created execution errors, what are the downstream impacts? What services, what systems, what people have been impacted by these decisions? And then likewise with governance, with model-centric AI, controls are focused at the model boundaries. So it's just simply input and output. But then system-centric AI, it goes beyond the model. The controls have to be distributed across the wider system. And that means we're talking about the data that's been interacted with the system, the tools, the actions that are being carried out, the workflows, all of those touch points. That's where the controls need to sit, as well as the model itself. So the key thing to recognize here at this juncture is that with enterprise AI maturity, it depends less on the model capability alone, but it's more about the system that's been built around it. And naturally, as AI becomes system-centric, so does the risk. So again, we're not talking about did the model respond correctly. That's no longer the simple question. It's about did the system act correctly? What does that system have access to? The permission levels that it has, on whose behalf is it acting? How is the system interacting with other systems? And what downstream workflows are being triggered by its decisions, by its actions, and so on and so forth. So ultimately, that makes identity, observability, and control part of system design. And when we talk about system design requirements, identity, observability, and control, they cannot be compliance afterthoughts. Because if you're only thinking about it at the last stage, you already missed it. They have to be thought about and implemented from day one, at the very least designed from day one and considered. All right, so this shift I've been talking about, I've focused mainly on an architectural point of view up until now. So we're going to talk about how this shift manifests in terms of what enterprises are building today. And what we've seen, which is quite obvious, is that different sectors, they're building AI for different things. So it's different use cases, they have different contexts that they're operating in. That makes sense. But there is an underlying pattern that we've observed here, and I'll walk you through that. So first, you start with the regulated trading and financial services. We've seen that a lot are building internal agent platforms with a key requirement that decision-making and actions are bounded. So there's controls and policies set in place that they cannot operate outside of. And that means for them, provenance, explainability, and auditability must be thought of from day one. Makes sense. You operate in a regulated environment, you have obligations that you have to adhere to, or you suffer the consequences. Moving over to healthcare systems, we've seen a different pattern, slightly different anyway. So we've seen agentic fleets are smaller, and obviously they require governance. We're seeing that these agents, they're being used for mixed use cases. Some clinical, research and front office type of work, others for back office workflows. The requirements that we've picked up from this sector, or at least what we've observed, is around AI-specific telemetry, monitoring, and assurance that goes beyond what traditional tooling can offer today. Then the third sector is the global IT services. And again, it's a different pattern. Now we're talking about agent-enabled delivery. And it's delivering software or services to clients with completely different environments and different controls that could be applied. And here, the key challenge is around the guardrails, that they must be enforceable, but the guardrails, they cannot break software delivery. And that makes sense. Again, as a developer, imagine you're building a feature and you want to leverage Agentic AI for that, and then you want to use your GitHub MCP or an MCP that you've even built yourself, and then the agent's being blocked by the governance tool from upstairs. That will be immensely frustrating, and then that will kill that productivity gain. Anyway, so these three sectors, three different use cases, but then the consistent design lesson appears here, and that design lesson is that when we talk about mature adoption with AI, again, it's not about model capability. Models wasn't the main thing that came up here. In some contexts, it does. Some organizations, they don't want to use certain types of models or models developed in certain regions. That's granted. But that wasn't the key requirement that we're picking up. What we identified is that success for these organizations and mature AI adoption was about how intelligence is shaped by the workflows that each organization needs to develop, and understanding how those workflows will be deployed in real environments, and obviously the control requirements that need to be set around them. So in other words, the problem of governance has also become system-centric. All right, so we talked a little bit about how enterprises are building AI today. This is a fun topic for me. So why the demo looks so great, and then why deployment is much more of a challenge. And of course, if anyone has built an AI demo, you're probably right here with me. But when we talk about setting up a demo, whoever's working on the demo, you've got a clear use case. You create your prompt. That prompt doesn't change. It has to stay the same. You set up your data. Again, please don't touch the data. And then finally, you get some visible outcome. And then you show that to your CTO, You want to get this built into the product ASAP. And then, of course, they get excited. So the key thing to recognize with demos is that fundamentally, they're working off of happy paths. They're working off of things that are expected to happen in terms of when it's operating. But when we talk about deployment, that's getting dependable outcomes in real workflows. That's where the challenge arises, and that's where the obstacle course begins. You can tell I'm from London with the second chart I've got here. But let's start with workflow integration. So we're no longer talking about curated data sets that were created for controlled environments. We're talking about real data. We're talking about real tools. We're talking about data that has implications if you mix PII from different customers, or tools that may or may not operate the way that you expect them to, or how you expect them to. We're talking about operational circumstances in production environments. That is not accounted for in any demo. So that's where you really got a gap between the expectation and reality. The second point, operational traceability. So it's not enough for that task to be carried out successfully. You need to understand what the agent did, why it did it, and what was the action sequence. How did it go from step by step till it reached that outcome? Without that, you can't describe anything in terms of decision-making. You can't, especially from a regulated point of view, provide the decision-making behind those actions. Then finally, you've got cost and control at scale. So again, even if this workflow is successful, the workflow still has to be governable. You still have to be able to set controls in place to ensure that it works within the boundaries that the organization cares about. It has to be safe, and of course, it has to be economically viable when operating in production environments. So the key thing to understand when we're talking about demoing versus deployment with AI, the hard part is not about setting up the prompt or setting up the input or the controls. The hard part is building the system around these models and having them work reliably, deliver value reliably under real operating circumstances. And it's no wonder why legacy governance breaks. Once AI, and as we've seen, AI is becoming more and more agentic and more system-centric. Because again, we're not dealing with models in isolation. It's not about whether you're using GPT 5.3 thinking or Opus 4.7. I can't wait for the next one, by the way. But it's not about the model capability alone now. It's about systems. So first, when we talk about gateway blind spots, and obviously, gateways are traditional security technologies, helpful for governance for traditional software. But monitoring model inputs and outputs, or monitoring network traffic, that doesn't give you full visibility. You need to understand the end-to-end workflows that these systems are operating in. You need to understand the tools that they're accessing and what the interactions look like, the behaviors of these tools, the data that's been accessed and modified, whether that data is production databases, or if it's a CRM, or if it's pushing data to the external network. So all of that you don't get with a single choke point monitoring or control. With dashboard bottlenecks, counting the AI models, counting the apps that's being used, or what agent types are being used, if people are using Claude Code or Cursor or what have you, that's important. Don't get me wrong. You need that visibility. You need to understand your agentic footprint. But again, that's not enough. You need to understand the workflows that are being carried out. What work is actually being done by these agents, and what are the outcomes? If you don't have that visibility, then you're missing out what matters most. And then finally, audit collapse. As I've mentioned, and for me, as far as I'm concerned, this is a requirement that spans organizations, no matter the sector. But traceability, understanding what the agents have done, why they did those actions, and on whose behalf they carried out those actions. Because without that understanding, accountability can never be strong for your organization. So this naturally leads us to the question, what does mature AI adoption actually look like in practice? And for me, in a sentence, is distributed visibility, but retention of control. And what that means in practice, so I'll start off with the first element, centralized policy, distributed visibility. So your traditional governance teams, your security teams, they're the centralized teams that control governance. They control the policies. They define the guardrails. They define the boundaries that the organization cares about. But the teams that deploy the actual AI systems, they have context these centralized teams don't. So they need visibility to understand what their agents are actually doing as well. And they should understand how these controls impact the agents. Why? Because when they see the risks that are affecting their agents, they have context they can use and act upon those risks. The second element, system-level telemetry. So again, not just monitoring models. Mature AI adoption, mature governance goes beyond that. That's understanding the entire system behavior. That's understanding the tools that are being invoked, data that's being accessed, and what have you, if other agents are being spun up, and why. Understanding that overall behavior enables you to understand the full action chain from start to finish, and also the outcomes. And then finally, the controls that enable work, and this is a key one, and something that we've actually observed, we've gone back and forth with a couple of organizations, but we're starting to see convergence around this. And that's the mature governance is not just about blocking tools. Department of No, if anyone is familiar with the term. That's not enough. There's obviously useful use cases where you need to block. Malicious software, malicious MCP, you don't need to go back and forth with anyone in the team. However, mature AI adoption, it demands controls that enable real work to be done. So that means controls that enable these workflows to be effective, but still to be safe, and again, operating within the boundaries that the organization cares about. So the thing to recognize here is that when we talk about mature AI adoption, we're not talking about maximal autonomy. We're not talking about agents that you just give them a task, it goes off to the mountains, 3 days later, it comes back with a solution. We're talking about maximum operability. So that means there's clear ownership on who owns these agentic systems. There's measurable outcomes, understanding these workflows, what work is actually being done, and understanding how effective these workflows are. And then there's clear escalation paths, because things will go wrong. So when things do go wrong, we know what to do. And these systems, they know what to do. So if there's one thought that I can leave you with, is this. The next era of enterprise AI, it won't be won by the organizations that have the most access to the best standalone models. Now, model capability is important, and it will continue to be important. We've seen this. We've seen the power of improving models, multimodal models, and so on. But what we've seen, and what we're continually observing, is that the enterprise advantage is more about the systems that are built around these models, and enabling these systems to deliver value consistently, again, under operating circumstances in production environments. So those who will win are the teams who know how to embed intelligence into real workflows that generate value for the business, and who can embed that intelligence safely, auditably, and at scale. And very quickly, for me, a simple recipe to approach this is first, think systems. 2, design for constraints. 3, measure outcomes. And then finally, you make governance an enabler and not a blocker. Thank you, everyone. Hope you enjoyed the talk, and I'm happy to take questions.
Thank you so much. What an incredible start to the day. You really kicked us off. I do have some questions from the audience here. Thank you. And you can also jump in now and thumbs up the ones that you like as well. The first question is, we've all heard stories about AI exceeding the bounds set for it. How do we mitigate that risk?
Right. Yeah, so there's probably a couple of layers here. I'll probably start off from the foundational model layer. So that's the element of how these models are built, how they're being trained, because obviously if you read up and you follow model development, what they're observing with controlled experiments is that models, especially when you set certain controls in place, you have monitoring in place, they can find ways to be deceptive. They can find ways to gain the system in order to beat those controls. So that's something that is a challenge, of course, but there's obviously targeted research around making models safe and trying to avoid these deceptive characteristics. Again, it's also based on the data they're trained on. When we talk from an operational sense, it depends on what you're using for governance and control. So at the application layer, and I'm speaking like for applications such as Cursor, Claude Code, some of them are doing a good job. They're implementing these controls, and if you've been using them over the last year and a half, you will see a lot of features have come in, where controls are being employed naturally. So when your agent goes off to write code, it gets automatically blocked when it tries to run a shell command on your machine. And you can now determine if you want to allow it or if you want to block it. So those types of controls are important. And then, of course, The governance layer is more for the organization. And that's where you need, obviously, tooling. This isn't something that we can just talk about and then the solution appears. You do have to create tooling or have the right tooling to tackle this. So I think the last element here is obviously having tooling that can block when you need to block, but also guide when you can. So feeding context back to these agents to allow them to understand risky actions or unsafe actions and guide them towards carrying out the action that they want to carry out, but in a safe way, or just blocking that action completely if it is deemed unsafe. I think those are 3 areas I'd approach it. Of course, there may be other ideas there.
Thank you. This one is, how do you make governance an enabler, not a blocker? Surely governance is more important than ever in the age of agents.
Again, this is an interesting question. Obviously, luckily, I work at Geordie AI. I'm not going to give them a plug here, but that's exactly what we exist for. That's a major challenge, and there's 2 routes you can go here. Again, one is the route of control and blocking and preventing, unsafe actions. For us, that's important, but that's not the approach that you should be looking at, for me anyway. Because the value we get with AI is productivity, the ability to push a lot of work that could have been done over 2 weeks in a matter of hours. And obviously, you get creativity benefits as well. But ultimately, you need to be able to help guide these systems. And for me, is again leveraging whatever context we can apply to help these systems. So if it's risk analysis on the posture of the agents, if it's risk analysis based on the activities of the agents, if it's based off of the actual workflow. So if this is an agent operating in marketing, a marketing agent shouldn't really be accessing production databases. So that context is something that should be fed to agents and, of course, the controlling teams, so they can know where to apply blockers, versus, obviously, agents operate with development teams. They may be a bit more lax, but again, there's still risks that they don't need to be aware of. So that's the high level, but it does come, again, back to the tooling they have available, and really is your approach. Do you want to enable real work to be done?
It's kind of interesting, because I feel like a few years ago in the world of business, it was all about everyone should see everything in the whole business and it should all be completely transparent. And now it's but you don't need to see all of the data actually. So it's kind of shifted direction slightly. This question is, how can we design robust systems yet remain flexible and make the most of the tools and models which change so fast?
For me, the starting point, again, comes back to system design. So you need to understand, as far as I'm concerned, is the workflows. What do we want to leverage AI for? What are the workflows? What are the tasks that we want to achieve? Now, obviously, AI is almost like a general purpose technology. You can use it for anything. But when you're now trying to build this into work and business processes, you need to understand the end-to-end. And then you need to understand, okay, now not just about taking this task from start to finish. What are the things that can go wrong? And there's that level of analysis that you need to pick up from day one. You identify the touch points, you identify where systems can interact, and you can get weird interactions. And how I'll look is like this. With traditional software is based on code. Code is deterministic. But we've seen for decades that with systems, we get bugs to this very day. We get vulnerabilities. And this is just with deterministic code. Add on top of that the layer of intelligent systems that are non-deterministic, that can hallucinate, that can be manipulated. So you have to look through the entire system. You have to understand all of the components, how they interact, and then you design for those interactions from day one.
I think we've got time for, a couple more. First steps that a company can take to move from model-based to system-based AI use.
So what was the question?
First steps that a company can take to move from model-based to system-based.
Yeah, I think I'd again start with the use case. Understand the use case, understand the workflows. Model-based, again, is going to be very limited. For me, I use it to create these slides. I was using Notebook LLM. It was messing me up. So I said, okay, let me go to GPT. And then obviously GPT did the job. But I don't create presentations as part of my day-to-day work. My day-to-day work is about building software. So we look at, okay, what are the key systems that we're building and expanding upon? What are the areas of value we want to deliver to users? And again, it's all around agentic. But then that's the starting point for me. So understand what we want to deliver, and then we say, okay, now how does AI actually help solve this problem? Because again, AI is not always needed for every problem. So that's something that's really important to recognize. Then you go from there, designing out that end-to-end, and you start to integrate. You move from just one person going back and forth to having something that's built and obviously multiple people can interact with.
Do you think we're getting to the point where people want an AI for every problem?
I think that's a mistake that people can easily fall into, because until you understand your use case, understand what value you want to deliver, you can accidentally just throw AI at it, and without understanding how AI works, again, where we are today, it will still improve. So it will get better. In 2-3 years, it'll probably be slightly different. But until you understand what AI can and can't do, you can fall into that trap. So understanding the use case, understanding what value you want to get out of it, then where does AI help us? And then where are all the other elements that need to come into play? And obviously, how do we control this? How do we ensure that it's not going to fail? And so on and so forth.
Thank you. This question, can you give an example of a demo project that you took all the way to deployment as mature AI, by your earlier definition of mature AI?
I can. It's
being
not
tested here.
Yes, and it's tested. Okay, so when we say AI, it's more at the model machine learning level. It wasn't as much of the LLM, even though we do use in internal workflows. But yeah, machine learning models we built for cybersecurity use case. I won't go into the details, but basically we built classifier. This started as a research project. We demoed to show that this can start to classify certain malicious activities. But then building that, and especially for regulated contexts, because we're delivering for regulated clients, we had to think about how, really start from the end. How is this actually going to be used? What decisions are going to be made off of the outputs of these models, and what actions can be made? And when you start from the end, you really see that it's not just about the model signal, the classifier, whether it classifies something as 1 or 0, but it's a lot more than that. There's a lot of components that come into play. So that was actually a major part of my work in my last role. And obviously that was successful, because the product is out there now.
I'm going to ask this one. I don't know if you have put a plant to plug Geordie AI in the audience, but the question is, what is the story behind the name Geordie AI? Are you from Newcastle?
First, I promise I did not put a plant, so let's just get it on the record. So Geordie AI, so the 3 co-founders, Henry, Hannah, and Benji, they latched onto this story from based in Newcastle. So there was a lamp. Let me take a step back. Sometimes my mind goes a bit too fast. In the Industrial Revolution, coal mining and so on, obviously that was a major activity, for energy and so on. But there was a danger of, you get noxious gases that are released as you're mining. And obviously, that's a serious risk of life. So someone developed a lamp which is called a Geordie lamp. And that lamp was basically able to detect when these noxious gases got to a level where it's becoming dangerous. And then once you get to that level, the lamp goes out, and that just gave a clear signal for everyone to just, back out. So that idea of around enabling people to work fast, but also maintaining safety and security, that's where we took off. And obviously, just applying that now with the agentic revolution is the metaphor there.
Amazing. Thank you so much. That's my favorite kind of storytelling, which is, how did you get your AI name? Well, in the Industrial Revolution. I really enjoy that. Thank you so much. You've started the day off so beautifully. Please give a big round of applause to Colin Nwachukwu Ife. Thank you.
Thank you.